In section 2.1, we introduce functions and their graphs. We will use function notation, evaluate functions, determine domains, interpret graphs, work with piecewise rules, and apply the vertical line test. A function is an input-output rule. Every permitted input must produce exactly one output. We write the output as f of x, where the parentheses contain the input. The domain contains the permitted inputs, and the range contains the outputs actually produced. Remember that f of x does not mean f times x. Those parentheses have a job, and multiplication is not it. This relation is a function because no input is paired with more than one output. The output 4 is repeated, and that is allowed. Functions control the number of outputs per input, not the number of inputs per output. A one-to-one function gives different outputs to different inputs. A many-to-one function allows several inputs to share an output. Both are functions because each input still has exactly one arrow leaving it. To evaluate a function, substitute the given input everywhere the variable appears. Use parentheses around negative or algebraic inputs. This small habit prevents sign and expansion errors. Substitute each requested input into the same function rule. For a plus h, replace every x by the entire expression a plus h and then expand carefully. The difference quotient begins by finding f of x plus h. Substitute x plus h everywhere x appears, and then place that result into the quotient. Keeping the fractions organized is half the battle. Use a common denominator, expand the numerator, and simplify. A factor of negative h remains and cancels with h. The original restrictions must still be recorded, even after a restricted factor disappears. In y equals f of x, x is the independent variable and y is the dependent variable. We choose an input x, and the function determines the corresponding output y. When no domain is stated, use all real inputs that make the formula meaningful. Denominators cannot be zero, and even roots require non-negative radicands. A square root in a denominator requires a strictly positive radicand. For the square root function, require the radicand to be non-negative. For the rational function, exclude the zeros of the denominator. The polynomial has no algebraic restrictions, so its domain is all real numbers. This formula has both a square root and a denominator. The root requires x to be at least negative 1. The denominator excludes negative 2 and 2, but negative 2 is already outside the permitted interval. Because the square root is in the denominator, 36 minus x squared must be strictly positive. Solving gives x between negative 6 and 6, with both endpoints excluded. Cutting squares of side x makes the box height x. Each original side loses x at both ends, so the new dimensions are 20 minus 2x and 14 minus 2x. Their product gives the volume. The physical dimensions must all be positive. Combining the three inequalities gives 0 less than x less than 7. Context can make a domain much smaller than the algebraic formula alone suggests. The graph of a function contains every point x, f of x. To read f of a, locate a on the horizontal axis, move to the graph, and read the corresponding vertical coordinate. At x equals -2, the graph has height 3, so f of -2 is 3. At x equals 1, the height is -2, so f of 1 is -2. Read the domain from left to right and the range from bottom to top. The graph begins at x equals -4 and ends at 5. Its lowest height is -2 and its highest is 4. A table of values can help reveal a graph. Choose useful inputs, compute their outputs, and plot the resulting points. Good input choices reduce arithmetic and reveal important features. The graph of x squared minus 1 is an upward opening parabola with vertex 0, -1. Its domain is all real numbers, and its range begins at -1. 4x squared minus 5x plus 6. The vertex occurs at x equals 5 halves and has height -1/4. The parabola opens upward, so that height is the minimum value. Perfect squares give convenient points on the square root graph. The graph begins at 0, 0 and extends to the right, so both its domain and range are 0 to infinity. A piecewise function uses different formulas on different parts of its domain. First use the input to select the correct rule, and only then perform the arithmetic. Graph the line only for -x and the parabola only for non-negative x. The open circle excludes 0 from the first rule, while the filled point includes 0 in the second. Only one rule gets custody of the boundary point. The vertical line test checks whether any input has more than one output. A curve represents a function exactly when every vertical line intersects it at most once. Graph A passes because each vertical line meets it at most once. Graph B fails because a vertical line can meet the ellipse twice, giving one input two different outputs. The main ideas are the definition of a function, function notation, evaluation, domain and range, graphs, piecewise rules, and the vertical line test. These ideas will support nearly everything we do next. A function can be represented by a formula, a table, a mapping, or a graph. In every representation, the defining rule remains the same. Each permitted input gets exactly one output.